Alright, so our second topic for tonight is going to be Stemplots and Dotplots. These are two types of displays that you can create to represent quantitative variables. Remember, we just learned about how to create graphs for categorical variables, so here's the beginning of talking about graphically displaying our quantitative variables. And the first type of display that we're going to talk about are Stemplots. So here's some data that we're going to be working with throughout this lesson. It's the number of pairs of shoes owned by a randomly selected group of 20 students. So you'll see this data pop up a few times as we go through this lesson. So first of all, let's talk about what a stem plot is. Sometimes they're also called stem and leaf plots. The reason for that is that you take each of your data points and you break it up into what's called a stem and a leaf. Now, here I've given two examples. So let's say that our data point is 50. Then what we're going to do is we're going to break that up into a leaf of 0 and a stem of 5. You have to keep in mind that when you're creating a stem plot, your leaf can only have one digit in it, and then the stem is just however many digits are left over. So for instance, if you had the number 123 in your data set, then your stem would be 12 and your leaf would be 3. Again, the leaf is just whatever that last digit in the number is. So another example from our data set on the number of shoes owned. If it's 57, then again 5 is the stem, 7 is the leaf. Pretty simple. So let's go back to that data set and create a stem plot out of it. Now the first thing you're going to want to do is take a look at the data in general and try to figure out what your minimum value is. In that case, or in our case, it looks like it's 13. And also figure out what your maximum value is. And it looks like that is 57. So we're going to need to make sure that we have enough stems to account for all of the possible values between 13 and 57. So that means our stems are going to range from 1 up to 5, because we're going to go from 13 up to 57. So we've got 1, 2, 3, 4, and 5 are our stems. And then whenever you create a stem plot, you're going to draw a vertical line. Hopefully I can draw that straight. That's a little better. And that's just going to show the separation between your stem and your leaf. And then here's the only hard part to this process, and it's not even that hard. What we're going to need to do then is write in our leaves for each of our data points. And you want to keep in mind that you're always going to go from the inside of your stem plot to the outside in ascending order. So here's what I mean. We have a stem of 1, and with that stem of 1 we're going to have 1, 2, 3 values of 13, of 15, and 19. So in order for, there we go. So in order for our stem plot to convey as much information as possible, we want to write our leaves in ascending order. And even if there's a repeat, you write one leaf for each data point. So we've got 3 13s that show up in our data set. So that means I'm going to write 3 leaves of 3. And then we have 1 leaf of 15. So I'm going to write a 5. And then we have 1 leaf of 19. So I write a 9 there. So those are the 5 data points that fall between 13 and 19. So now we're going to move up, and I'm going to cross those out just so we know they're done. So now we're going to move up to all of the data points whose stem is a 2. So it looks like we've got 2 26s, a 23, a 24. You probably can't read my awful handwriting. That should be a 4. My apologies. And then, let's see, a 22 and a 23. So in that row, the 22 is the smallest data point, so a 2 is going to go first. And this is a little hard for me to do on the iPad, but when you're creating a stem plot, you want your digits to show up in columns as much as possible. And I'll explain why that is in just a minute. So we've got a 22, 23, another 23, 24, and then two 26s. Oops. 26 and 26. Okay, so now we've taken care of that row. Next, we need to go to the data points that all have a stem of 30. Looks like we have 30. And even if it's a digit, or a value that ends in a 0, you still have to account for that 0. So our first leaf in this row will be a 0. And then we've got 31, 34, and 38. So that's what that row is going to look like. And we're just about there. We then only have a 49 in the next row. And then we have a 50 and a 51. And again, I've done my, oops, excuse me, I screwed up there. We have two 50s. Two 50s. There we go. That should be everything. So again, I've done my best to make sure that things are lined up in columns as best as possible. And the reason for that is that you want to be able to get a sense for how your values are distributed. If you write some of your numbers really small and some of them really big, then you might not be able to tell where a lot of your data is. But we can see pretty easily that most of the data lies down here in this area, even in this 30 range. So it looks like there aren't too many people who have a ridiculous number of pairs of shoes. But we do have these folks up here who are taking it to the extreme, for sure. But again, that's just a basic idea of how you are going to create a stem plot, or a stem and leaf plot, if that's what you want to call it. Now, there are some other things that we can do with stem and leaf plots. There is an idea of a back-to-back stem plot, and that can be helpful if you're trying to compare distributions for two different data sets. So I've already written this back-to-back stem plot out, but let's take a look at what's going on here. So we've got two different sets of data. Again, this is with number of pairs of shoes. And we've split it up between the females in the group and the males. And then we have created two separate stem plots for each of those two groups. And we've just shared the stems here down in this column. And then the leaves for the two groups show up to the left and to the right. Now, the leaves for the males data works just exactly the same way as the leaves did on this stem plot that we just created. You do need to be careful if you have a back-to-back stem plot. What's on the left side works a little bit differently. Notice that, like I said before, your data is going to go, the smallest leaves are going to be in towards the stem. The largest leaves are going to be away from the stem. So let's take a look at this row right here. Notice that it starts with a 2 towards the center, 2 values of 3, and 1 value of 4. And let's just make sure we understand what this represents. For instance, if we're looking at this leaf of 5 right here, well, what does that mean? That means that there was some female in this data set who owns 15 pairs of shoes, because again, the stem is 1, the leaf is 5. What does this 0 down here represent? Well, that's a female with 50 pairs of shoes, a stem of 5 and a leaf of 0. And then on the male side, you would read it just the way we would read it from, or similarly to the way we would read the data from the stem plot that we just created. So for instance, this 2 right here represents a data value of 22. And hopefully that makes sense, but if you're a little bit confused, just let me know and we can talk about it in class tomorrow. Now, the other thing that I want to point out from this stem plot is that we have what's called split stems. So you might have noticed that there are 2 zeros, 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, etc. And the reason that we've done that is because there are so many data points that would fall within a certain stem. For instance, notice how many data points have a stem of 0 for the males. We've got 1, 2, 3, 4, 5, 6, 7, 8 data points. That's a lot, and if your leaves go out too far, it can be a little bit difficult to see to really see the shape of your distribution. So what we can do is split the stems. And what that means is that you write each stem twice, like we've done here. 2 zeros, 2 ones, 2 twos, 2 threes, 2 fours, 2 fives. For the uppermost stem, you're going to write any leaf between 0 and 4. So notice here, we've got this 4. That represents a male. Poor thing, he only owns 4 pairs of shoes. And then for any leaf between 5 and 9, that's going to go in the next row. So if we go down one row, this 5 right here represents a male who owns 5 pairs of shoes. And then you just continue with that same idea. So for the ones here, the stems are split again. This 3 represents a female who owns 13 pairs of shoes. So any any leaf between 0 and 4 would show up on this row. And then any leaf between 5 and 9 would show up on this row. So that's why we have a data point of 15 here and a data point of 19. Again, the whole purpose of splitting stems, like we've done on this example, is just to make the shape of the distribution a little bit easier to see. Because we've split the stems, it's pretty easy to see that most of the data for the males is clustered down here. These poor guys don't have too many pairs of shoes, and it looks in general like the females have far more pairs of shoes. Look at this. This girl's got 57 pairs of shoes. That's ridiculous. Now, say what you will. This is not meant to be sexist in any way. But it looks like from this data, overall, we can say that females have more pairs of shoes than males, which may or may not shock you all. Okay, so that's stem plots. The next type of graphical display that we want to talk about are dot plots, and they work pretty much the same way as stem plots, except you might not be surprised to find out you're going to use dots. So we've got that same data that I showed you a little while ago on the number of pairs of shoes. In this case, we're not differentiating between males and females. It's just all kind of lumped together. So if we want to create a dot plot from this data, you're going to first draw out just a horizontal line, and then you want to make sure, like we did with the stem plot, that you take a look and find your minimum values and your maximum values. So it's going to be the same as before. We've got a minimum of 13, a maximum of 57. And once you have that information, you're going to want to create a scale on that horizontal axis that you just drew. So since we have a minimum of 13, I'm going to start at 10, just because I like nice round numbers like that. And since our maximum is 57, I'm going to go up to 60. And then you want to make sure that everything in between is evenly spaced. So let's see, here we've got 30, 20, and that will be 15, 25, sorry, totally lost what I was doing. That would be a problem, wouldn't it? Sorry. Scratch that. The difference between 10 and 60 is 50, isn't it? So halfway is just going to be 25. So we are just going to be at 35 here. Pardon me. So we need 10, 15, 20, 25, 30. That looks a little bit better. And then we'll have 40, 45, 50, 55. Pretty close. Okay, so once you've got your axis set up, like I said, dot plot just means you're going to draw a bunch of dots. So each data point is going to get a dot that corresponds to it. And the value of the data point tells you where to put the dot. So as we saw before, we've got 3 13s. So I'm going to go over and approximately where 13 would occur. This is going to be a little tricky with the iPad, but you'll get the idea. So a 13 is going to be, let's see, 1 dot should be right about there. No, come on. There we go. And then I'm going to draw 3 of them total. So there's 2, and there's 3. And again, well, maybe. There we Just as with the stem plot, you want to make sure your dots are evenly spaced, again, because if you cluster them really close together in one area and spread them far apart in another area, it's going to give you some incorrect information about the distribution of your data. So we've taken care of the 13s. Next one, we've got one data point at 15. Then we've got one data point at 19. Oh, this is frustrating. Here we go. Let's see, what else do we have? We've got a 22. Maybe. There we go. A 23. This thing really does not want to cooperate with me. There we go. And a 24. So 23, 24 is taken care of. We have 2 points at 26. Sorry, this is taking so long. Oh, we've got another one at 23 that I missed. Let's see, 23 was right there. What else do we have? We've got a 30 somewhere, right? Yep, 30. We've got a 31. We've got 34. 38. 2 50s, 49. So notice, unlike with the stem plot, you don't necessarily have to go in exact order with this dot plot since you're just making a bunch of dots. And then the last, whoops, let's see, oh, that's 57. Nope, we've got a 51 here, and then a 57 up here. There we go. And that should be all of our data points. So here's our lovely dot plot. As with the stem plot, it does give you a sense for how your data is distributed, what the shape of the distribution looks like, but there are some downfalls with the dot plots in comparison to the stem plots because you don't get the exact value. In this case we did, but not always, depending on your scale. You don't always get the exact value of each of your data points. So just something to keep in mind when you're choosing between whether to create a dot plot or a stem plot.